Hello, I'm Brett Peterson, EVP of Business Development. I work with organizations to develop strategies that allow them to leverage our software and services to reduce risk, enhance system readiness, and lower the total cost of ownership of their system or asset for that full life cycle. Let me give you a quick introduction. We were established in 2006 and are a privately owned company. We are incorporated out of San Antonio, Texas, and have over 40 staff members currently working at PHM technology. And we have offices throughout the world to better serve and help our customers, as well as expanding our footprint. Let's now look at how our digital framework enables a seamless transformation from disconnected data to actionable model-based decision support. MADE, which stands for Maintenance Aware Design Ecosystem, is the foundation of our model-based RAMS approach. It enables engineers to generate a digital risk model that becomes the backbone for analysis, validation, and decision-making throughout the design process. The MADE suite consists of 4 software modules. The first, system modeling. Next, system and risk, or safety and risk assessments, or SRA. The third is a RAM for reliability, availability, and maintenance. And our 4th software module is our PHM software, which is our prognostics and health management. What does MADE do? MADE generates a digital risk model used to identify, analyze, and mitigate engineering risk early in the design phase. As the model matures, it becomes a digital risk twin, continuously updated with operational data. What you're seeing here is the MADE modeling canvas where you start to build your digital risk twin. Let's talk a little bit about technical risk. It isn't just about what can go wrong, it's about how it impacts safety, readiness, cost, and potentially the mission at hand. In complex mission-critical systems, failures mean downtime, economic impact, potential certification issues, and in some cases, loss of life. What you're seeing here is the maintenance-aware design ecosystem, known as MADE. This is the software canvas where the digital risk twin is generated. And that is based on your system's configuration and engineering topology. You can see how a failure on a specific function propagates through the system. This is what we call auto dependency mapping. You're able to see the impact on each function downstream and the overall effect at a system level. Each function puts off a failure syndrome, and I'll touch on this in just a minute as to why this data is incredibly useful and important to capture. Our software allows you to identify, analyze, and mitigate failures at the earliest possible design phase. You can perform analysis on your system to identify and capture potential failures early in the process. And these are typically categorized into 3 main types of failures. The first, non-critical identified. Now, these are still important to notate and recognize. Next are the critical identified. These allow you to review and possibly build in redundancies, redesign, or put in the appropriate maintenance periodicity to prevent unplanned failures. Now the third, in red, critical unidentified failures. These failures typically result in the greatest economic impact, significant downtime, and cause the most headache or heartache. These typically happen while in operation and make it far more difficult to remedy. Our digital risk twin allows you to put in the appropriate mitigations to Build a more resilient, reliable system that helps you lower the total cost of ownership over the lifetime. Many have asked, why model-based RAMs? Well, it enables early risk identification and mitigation in that design. It also automates failure and hazard analysis and drives continuous optimization. As we look at how model-based RAMs fits into your broader digital ecosystem, let's talk about integration and how we ensure a single source of truth across tools, teams, and platforms. MADE is designed to integrate seamlessly with the tools you already use, ensuring it becomes part of your digital thread, not a silo beside it. You can accelerate RAMs, that reliability, availability, maintainability, and safety analysis, by importing from Excel, CVS, SysML, Cameo, CAD, or even a bill of materials. We also have advanced APIs. This can allow you and help you auto-populate a significant amount of your digital risk twin. If you don't have any data and are just starting out, not a problem at all. We can walk you through how to best do that and to speed up that process. If you happen to have legacy data, we can show you how to leverage that to help you move forward with your digital transformation. We can show you how to use and leverage the power of MADE on your current legacy systems. The MADE software offers a full suite of RESTful APIs and is available to support enterprise scale integration. Whether it's feeding data to dashboards, simulation environments, or other lifecycle management systems. MADE doesn't require you to change your ecosystem. It enhances it by connecting RAMs directly to the rest of your digital engineering and decision support stack. Let's now move into our MADE platform, the model-based RAMs engine. The MADE system modeling module is where the power of model-based RAMs begins. Before jumping into the modeling itself, I always like to highlight that there are multiple ways to create your digital risk twin. As I mentioned, you can import from a bill of materials. Use our AI-powered FMEA ingestion feature. You can leverage integration with tools like Cameo, CAD, and SysML. These capabilities can automatically generate a significant portion of your model, accelerating that workflow. Additionally, PHM technology offers training programs and even a full service option where our team can build the models for you. This module generates the digital risk twin, a model-based representation of your system's architecture and failure behavior. It identifies and helps mitigate technical risk, both functional and physical, early in the design process and throughout operations. Here you'll see some of the areas within this software where you'll build out your mission profile, the model creation. We have a standardized taxonomy built into the software, where we have a formalized built-in taxonomy which allows you to ensure that each engineering discipline is using the same nomenclature throughout the life of the system. Failure simulation also allows you to run multiple iterations of your system to identify, analyze, and mitigate any potential weak points. Really, that value to the user is this model forms the single source of truth for all downstream RAMs tasks, eliminating disconnected spreadsheets and ensuring consistency across safety, reliability, and diagnostics. It's the first step in digitizing engineering knowledge and unlocking automation. Once the system is modeled, MAID allows us to rapidly transition into safety and risk assessments, automating what would otherwise be time-consuming and error-prone manual tasks. MAID's system risk assessment, the SRA, tool brings MIL Standard 882E hazard analysis into a modern, model-based environment. It lets you identify, assess, and manage hazards directly within your system model, ensuring full traceability from function to failure to risk. This module leverages the digital risk twin to perform structured safety and risk analysis. It ensures consistency, repeatability, and traceability across all risk-related assessments, both during design and into operations. This helps you move away from manually producing key reports or artifacts and auto-generating these by a click of a button. These are all generated from the model. As you'll see here, you can do criticality assessments. Evaluate the criticality of each level within the system, platform, subsystem, and assembly, using either linguistic descriptors or numerical values. Also, reporting. This helps with certifications. You can stack rank your top 20 degraders or more, and auto-generate, as I mentioned, your FMEAs, fault trees, your failure hazard assessments as well. In regulated environments like aerospace and defense, these outputs are required for certification, but MAID transforms them from compliance documents into real decision-making tools. It also dramatically reduces the time needed to update, regenerate, or audit these analyses. The MAID platform brings RAM discipline, which is reliability, availability, and maintenance analysis, into a model-based environment where decisions are data-driven, interconnected, and continuously optimized. Here you'll see you can run your reliability allocation. There's a reliability editor, and this allows direct user input, also Markov analysis for operating states to quantify availability and reliability. Also maintenance cost estimates, so that you know the potential sustainment cost of this system throughout its lifetime. Reliability-centered maintenance. You can run simulations in this early design phase to optimize your reliability-centered maintenance plans. This module allows you to explore what-if scenarios in real time, comparing designs not just by performance, but by availability, cost, and reliability impact. This methodology empowers engineers to design for optimal readiness, not just technical function. PHM within the MAID platform enables model-based design and validation of diagnostics. This is essential for effective fault detection and isolation and long-term system resilience. The PHM module extends the digital risk twin to cover in-service diagnostics and prognostics. We believe that each sensor needs to buy its way onto your system. It enables you to not only detect faults, but predict them, isolate root causes, and verify sensor effectiveness, all within a single, consistent environment. Here you'll see some of those features. Diagnostic design for condition-based maintenance. This helps maximize failure coverage. It also has a feature for diagnostic rule generation. What that does is it has a detailed sensor outputs, and these are interpreted as failure syndromes for the purpose of fault detection and isolation. A big one is the annotation feature. As the silver tsunami approaches and experienced professionals retire, it is essential to digitize and preserve their domain knowledge and subject matter expertise, and this product allows you to do so. It also ensures diagnostics are not only designed but verified before deployment. Because we have a single model or a single source of truth, we can auto-generate all of your safety and reliability artifacts by a click of a button. This gets you away from manually authoring reports and allows these reports to become living, usable documents that can be regenerated at any time by a click of a button. Since they are all derived from a unified source model, the outputs are inherently more objective than subjective. These outputs are not isolated. They're all derived from a consistent shared model. This ensures high fidelity, full traceability, and faster analysis, enabling deeper system understanding and more informed decision making. Let me show you how MADE gives you deeper, higher fidelity insight into your system failures. Let's first discuss the PHM technology suite and how each software tool fits within the broader digital RAMS ecosystem. On the left side of the slide, you have the MADE platform. It starts with early risk identification, enabling you to uncover all potential and risk and understand how they propagate throughout your system. This approach gives you a clear, comprehensive view of their overall impact. Once all risks are identified, you can mitigate them by designing them out, incorporating redundancy, or integrating diagnostics with the appropriate sensors. Shifting to the right side of the slide, once the system is operational, the focus turns to managing actual failures. That's where mode or maintenance, optimization, diagnostics ecosystem comes in, enabling real-time fault detection and isolation, pinpointing issues, and supporting data-driven decisions. You're not just repairing faults or failures, you're continuously learning and enhancing your entire system in real time. Let's look at how PHM Technologies' ecosystem connects everything from people, processes, tools into one unified digital backbone. We're more than just a product, we're a complete ecosystem. From requirements through design to operations, we close the RAMS loop across the entire lifecycle. Here's an illustration of our PHM technology ecosystem, a next generation model-based framework that's transforming how we manage the reliability and safety of complex mission-critical systems. We'll dive into each piece of this ecosystem in more detail. As systems grow more complex and distributed, traditional RAMS, or that reliability, availability, maintainability, and safety methods, are starting to fall short. We need tools that integrate design, diagnostics, and sustainment seamlessly and digitally. The PHM technology ecosystem integrates the MADE software suite and Mode suite platforms via a digital RAMS backbone, bridging the gap between product lifecycle management and service lifecycle management. The ecosystem empowers teams to deliver safer, more reliable systems at a lower cost at greater speed. As we move forward, let's explore how MADE gives you a deeper, higher fidelity insight into system failures. On the left, we have system modeling in MADE. It's supported by mission profiles, environmental parameters, duty cycles, and hazard analysis. This provides the foundation for a high-fidelity digital risk twin. In the center section there is the failure pathway. The core of this slide visualizes a specific failure syndrome originating at the pump assembly and propagating through filters, injectors, engine, gearbox, and all the way to a loss of thrust. This chain represents how a seemingly isolated failure cascades across systems. We highlight the journey from root cause, local impact, next stages, and eventually to functional failure. With a traditional FMEA or failure mode effects analysis, you typically only see local, next, and end effect. But with our model-based approach, you can visually see how each function is impacted as the failure cascades downstream. This is directly derived from the model, so it's consistent and traceable. Why does this matter? Well, this visualization is what enables proactive engineering. You're not just documenting failures, you're understanding the system behavior under stress. It supports both design optimization and in-service decision-making. Syndrome Diagnostics, or SD, is part of our mode suite and is our real-time diagnostic engine designed to detect and isolate critical failures as they emerge using a causation-based AI framework. So what does SD actually do? SD ingests real-time operational data directly from onboard sensors and system diagnostics. It processes this data using causation-based AI, not just correlation, to identify those early warning signs of failure. How it works is the system recognizes signal patterns that indicate an incipient failure. Even before full degradation occurs, because we already know every possible failure pattern from our digital risk twin, our causation model. It then automatically triggers alarms and alerts based on system health, the system health state, enabling proactive maintenance decisions. Here you can see the real-time monitoring concept visualized. Sensors distributed across critical components like engines, hydraulics, and landing gear, all feeding into syndrome diagnostics. That data is then visualized, assessed, and actioned on the SD interface. What this provides is real-time fault detection and isolation. It allows for fast and precise pinpointing of root causes. It also offers residual life estimations which are coming in the near future. It enables planning for component replacement before unplanned downtime, as well as optimized system availability. It drives readiness and minimizes mission disruption. One key strategic differentiator is, unlike traditional condition-based monitoring or CBM systems, what SD does is it's integrated with the digital risk twin, providing alerts that are contextualized within a complete system model. We synthesize sensor data with an engineering causation-based model, not just through data science alone. That means you don't just know something failed, you know how it failed, and can trace the failure pattern from the engineering context, or that causation model, that digital risk twin, to pinpoint the root cause. You understand the impact and response in real time. Syndrome Diagnostics closes the loop from predictive modeling in MADE to live asset monitoring, so you can transition from reactive to predictive operations with confidence. This slide demonstrates the closed loop integration between MAID and syndrome diagnostics, enabling a continuous cycle of model refinement, diagnostic intelligence, and availability optimization. On the left, we have the MAID environment, where the digital risk twin is modeled and updated based on design data. On the right side, we see the live asset with its embedded sensor suite collecting real-time system outputs. Sitting in the middle is SD, processing data to enable AI-driven fault detection, isolation, and health assessments. The results are tangible. We get precise fault isolation, residual life estimation, which is currently in development, and an up-to-date view of system health, all feeding into maintenance operations. So now that we've explored the technical depth, let's shift focus and talk about what this really means for your business and the value of a model-based RAMS approach and what that delivers at scale. In this slide, we're looking at some of the key outcomes from using the MAID suite. The first area is less downtime. Across design and maintenance, MAID helps reduce unexpected failures, whether it's through better design decisions, optimized maintenance strategies, or improved failure cause identification with AI. The result is higher reliability and positions you from less penalty from regulators or any other contracts that you might have in place. The second outcome is lower total cost of ownership. By combining optimization strategies across both design and maintenance, we significantly cut servicing costs. Next, we've got knowledge capture. With the silver tsunami taking place, many SMEs or subject matter experts are retiring. MAID embeds domain expertise directly into the digital twin. So knowledge isn't lost when staff moves on. It becomes transferable across the team. Future readiness is a big one. Because MAID uses a standardized taxonomy, it sets the foundation for applying AI and advanced analytics in a traceable, consistent way. We also focus on resilience by design. With model-based RAMS, we design resilience into the architecture from the start, not bolted on later. That shift-left mindset is critical for modern systems. And finally, accelerated compliance. MAID automates a lot of the traditional RAMS deliverables, things like FMEAs, FMECAs, fault trees, reliability block diagrams, aligning with standards, but doing it faster and with less manual effort. So overall, the outcomes are clear: less downtime, lower cost, captured expertise, readiness for the future, and resilience built in, and faster compliance. That brings us to the end of the presentation. I appreciate your time. If you have any questions, please feel free to direct them to myself. My name is Brett Peterson. I look forward to hearing from you, and have a great day.